In this lecture, two-part one, we're going to have a look at architectural design, specifically as how it relates to 2D games. So in particular, we're going to explore different structures that you commonly find within 2D games. And hopefully it'll be of help by way then of giving you some framework elements that you can use when you are designing your own game. So we'll look at principles first of all within this one, and in the second part we're going to have a look at an example. And we'll start off with identifying some of the key components that we often find within a 2D game. And this actually is an exercise we'll do within the class, but it's useful actually to do yourself to spend a bit of time. It's a bit of a challenge, but distilling key components or actions. So the challenge is pick a genre, a 2D genre, any one you want. So some easy ones would be like a platform game or a racing game. More difficult ones would be adventure game or a puzzle game. But pick something. In terms of the module, maybe pick the genre you're thinking of developing your project within. And ask yourself, remember the examples of the different types of that genre that you have played, or go to YouTube and have a look at some common ones of the App Store and work out what's the most popular one, set of ones in that category. And then look for commonalities. Ask yourself, well, what defines that genre? What do most of them have in common? What are the commonalities in terms of how they interact or act? So in other words, what defines that genre? So yeah, try to identify common aspects that most games in the genre will share in terms of features and behavior. And you're going to do this, probably take about 10 minutes, and then you can come back and we'll carry on. In terms of carrying on then, so I have one example solution to this here. Now it is only an example solution. There is no correct or incorrect version to this. So this is one illustration of the types of things that 2D games can have. So things most 2D games have. I've got a list of them here, no particular order. Starting off with front end, so titles or menus. So most games, when we run them, they'll have a loading screen, a splash screen, a menu screen, and other sort of things around the main game itself. So different screens, and there's a bit of navigation through those. Games generally make use of assets. So by assets we mean graphics. So this could be images that are displayed, it could be animations that are played, other related things. Sound's another one. So either in terms of sound effects or maybe some background music that's playing. But most 2D games will make use of those raw resources, which means that if we're creating our game, we're going to have to get these things, we'll be loading them in, we'll be manipulating them, and so on. Games generally have objects, so things that we can talk about and refer to. They may be in-game objects. So depending on the game, these could be the player, could be enemies, could be a platform, could be coins. It just really depends on the thing. But anything that is game specific that we can refer to by a name, we can sort of think of as an object within that game. We can also generally identify other types of objects. We have down here is HUD objects. So if it is scores or life or a countdown time, some element that appears on the screen that the user can sort of refer to or interact with. But these are the objects, and if we're identifying the game as having these objects, the implication is that we as programmers are going to have to create them. We're going to have to create classes for them, to define them, to give them the functionality that they need. So these are things that will fall to us to implement. Less clearly immediate from a player's point of view, but games generally are structured in terms of having containers. And we've already somewhat mentioned this. We mentioned about having front end, about a splash screen, a main menu, a game screen. Often games have different levels or different regions or different maps. So very often within games there is this hierarchical structuring where we are grouping and breaking the game up into a number of sort of smaller chunks, be it in terms of levels or areas or maps or screens or whatnot. But again, that's a type of element that we'll want to replicate within our own designs. Last thing I have here, you could have more, but input events. So games need to receive input in to process and to use. And because we're thinking about an app-based system here, we actually have multiple forms of input in terms of camera, touch, the accelerometer, so on and so forth. Now, that's things that games have. Related to that are also things that games do. So we'll talk about their behavior, their functionality. I've got two groupings here. So one's per game or per level. So these are things that the games definitely do, but they don't do it that often. So load assets. Depending on the game, you may have a loading screen. So we will have to, as programmers, put in the work to load in all of the graphics and the sound that we need for that particular level or game screen. Beyond that, we also have to construct objects. So to create the level, we're going to have to create instances of things. We're going to have to, if it's a platform game, create the right platforms, position them at the right position, which suggests that there's some template or descriptor that we're working from to build up this particular game. And we're then populating the containers to get the game ready. Lots of times per second then, games generally consider input events as the user provided us with some input as to what he or she would like to do. We're updating objects. So all of the game objects we mentioned earlier on, the end game, the HUD elements, they are updatable. Some might just sit there and do nothing. Other ones may play an animation. Other ones may check for user input and then do stuff based on that, and so on and so forth. And the other key thing that games do is actually to draw then these objects to the screen. So we're updating them, changing their position, their graphical state, and we redraw them on the screen to communicate to the player what's happening. We also can play sounds as well as a way of communicating the actions and activity within the game. So that's some structure that we have in terms of things that we commonly find and commonly do within games. But bit at the bottom is important. There's no one correct answer to this, and you'll have your own particular one for the style of game that you want to do. It is useful doing this because this gives us terms, labels, concepts that we can then use when we're thinking about our game and help us to break up a complex notion, the notion of a game, into smaller, more manageable components, and to keep that process going until we get down to a stage where we can actually implement it. Now, what follows, we're going to look at game architecture in the abstract. So it's some of the underlying principles that can help us when we're designing or implementing our game. In this case here, it is going to be very much a mixed bag. So we're looking at one element, we're going to look at another element, we're going to look at another element. So we're just putting a lot of different modeling tools down that often we'll encounter and use within the games. Start off first of all with object-oriented design. So we will be using an OO design on this. Object-orientism, fundamental principle of that is that you're dealing with abstraction. You're taking something and you're abstracting it into the objects, the actors within that. And encapsulation is where we are grouping the behavior, the data within those objects. And for your game, you will want to identify the objects that you have within the game. You'll want to think about the behavior, what they do. So what this roughly means is, for example, what will this object do when it's updated? How will it draw itself to the screen? And what data does it need? What graphics does it want to use? What values does it have? Does it have a health? Does it have a score? Does it have a position? So all of these things. Now, you'll not get it right first time. That doesn't matter. What matters is getting these objects down and having a stab at what you think will be part of them. Then you will iterate that over time. Alongside that, there's also the broad notion of inheritance and composition. So how does the game object relate to other game objects? So your game will not be a random collection of objects. These objects will relate and interact with one another. So for all of the objects you're thinking, yeah, we'll need this object in our game, you want to think about, well, how is that object positioned, related to other objects? So some of the things there, where does that object live? Which collection? So for example, if it's a platform, maybe we have a level that has multiple platforms. And in saying that, what we effectively have said there is we have a platform object, but that platform object is grouped with other platforms. So we might have an array or an array list of those. And that collection of platforms then belongs within some other container, the notion of a level. So in that one statement, we have given ourselves a bit of a structure by way of saying we have a level class. We'll presumably have something like an array and an array of platform instances. So that's the type of way that we have of breaking this down. Is this object part of an inheritance hierarchy? So again, are there multiple different types of platforms? Is there a base one? Do we have ones that maybe move or otherwise interact, and a standard one that just sits there? So again, some things we'll be able to group together through inheritance and then to share and inherit behavior from it. Importantly, at the bottom, which objects, other objects will need to communicate with this object. So when we create an object, quite often other objects will be interacting with it. So if our platform object, maybe we want to be able to give that them access to the player object if the player wants to use this for collision detection, for example. But again, these are all decisions that we will want to make and to think about. Next one up then, but we're going to give you an example of a high-level grouping. So this is really just a visual way of illustrating what we're talking about in the last slide. So for your game, you'll be able to sit down, you'll be able to identify a number of objects. For the objects, you'll be able to think about, well, what does that object do? How should it update itself? How should it be drawn? You'll be able to think about what properties is it going to have in terms of position or score or whatnot. Having defined the objects, you'll be able to think about, well, how are those objects grouped together? Which ones are they related to? And potentially some objects can be part of more than one grouping, maybe. Also importantly, we want to define how one object or the objects it needs to talk to, and maybe put in a little bit of detail in terms of how it will actually end up talking with those objects. So in doing that, you can sort of see the structure that takes shape here. It gives us a way of visualizing this, and that's important working in a team, because then you have something that you can point to, you can share, you can talk about, you can change, and it's a much easier way then of communicating what's in your head with the other members of the team. And that can give you a bit of a framework, and you can then have something you can share by way of developing it. The other important thing not to forget in this is that whilst it's a game, we will also have a file system, an input device, a graphic device, a sound device. So there are things that these objects will interact with. So one object might be interested in loading in some graphics, which you'll get from the file system. That same object may be interested in checking to see if the user has provided input. So we need some way of accessing that. Graphics devices, sound devices, and so on. So the file, input devices, graphic devices, these are really independent of the game. They're things that are offered on the platform in which we are running. But it's important to model those, because we as programmers are going to have to write something that gives us access to them, and then to make that thing that we've written available to our objects so they can get access to graphics or whatever it is they need to use. Another way of looking at this, another model, this sort of ties it into the main game loop. So games run on a looping mechanism. They repeat things frequently. It could be 30 times a second, could be 60 times a second, it could be free range. And for each of our objects, the fundamental two actions that we apply, we update an object and we can draw an object. So update and draw, update and draw, update and render, depending how it's referred. So we can imagine we have a bunch of objects, it could be different types. These objects we often will want to put within a particular layer or map or level. The constructor for that will build those objects, and that may mean that we are pulling in data and graphics and other things. The layer then will have an update process, we'll have a draw process. When we update it, effectively we're saying we want to update the objects that belong to that layer. And when we say to the layer we want to draw yourself, then it wants to draw the objects that are contained within it. And you can see here under this model we can have more than one game layer. We might have a level 1, a level 2, we can have a main menu or different things. Top level, we then have our main game engine. So this is the thing that hangs, or the game hangs on to. And at the start of this we might be loading in any and all of the graphics that we need. We could be building the different layers. And we have our run loop. And it's at that level that it runs, that it says, okay, what's the current layer? What am I doing at this point? Am I displaying the main menu? Am I playing the game? Depending on what it is, it goes to the relevant container and says, well, update yourself, then draw yourself, update yourself, and draw yourself. And that iteration is what brings the game to life. Alongside that, yes, we can have asset management for accessing things, we can have input and all of the other surrounding elements that the platform offers. Collections, these are another useful way of thinking about things. We talked about platforms, and I mentioned you could have an array of platforms. So within the game, we are likely to have instances where we have a set of objects, and this is where data structures come into it. So data structures, fundamentally, they store objects. There's lots of different types, from hash maps to trees to sets, to you sort of name things. They differ in terms, fundamentally the only way they differ is in terms of the ease with which items can be added, the cost of adding or removing an item. So anytime you add something, there's a performance cost. Anytime you remove it, there's a performance cost. And the ease with which you can either iterate over the set or pull out one specific item from the set. So depending upon the need, if you have something that is a fixed size, you're not going to be adding or removing things to it, and it's important you can quite quickly jump to a specific one, then one data structure, something like an array, is going to be a better one than another one where you think, I'm going to be moving things and adding things very frequently. I'm not going to be doing random access. I'm only ever going to be accessing from the front to the end, or something like a linked list, maybe a more appropriate structure. Now, in your data structure and algorithms course, you'll be learning about this in great detail. In this course, I'm not going to cover it in much detail because you're doing it elsewhere. But for your groupings of objects, you will want to think about what is the most efficient data structure to group that collection together. And you can see a few examples of them on the screen here. Devolved versus centralized control. This is quite an important area within a game. So let's assume that we have a level. Inside that level, we have a bunch of objects. And the level has an update method that we're calling from our game loop. And the goal of that update method is to update all of the objects. And there's two primary ways you can do this: devolved, centralized. So in terms of centralized control, first of all, so effectively our level, its update decides precisely what all of the objects do. So effectively, the update at this point is centralized control. It says, object 1, you will do this. Object 2, you will do that. Object 3, you will do that. So it's all held at that one level, and each of the objects are told what it is they will do. Advantages to that is it is easy to coordinate behavior between the different objects. So if you have a bunch of enemies and you want them to move in a certain formation, then it's easiest, most times, to do that centrally, to have one process that says, you go there, you go there, you go there. The downside, or the disadvantage of doing this, is that it can be cumbersome to manage objects if they do different things. So if I'm looking after several different objects and each of them do their own thing, then the problem is my centralized control has to understand what each of them does, has to basically embed all of their behavior, and that can make it cumbersome. The other option we have is devolved or decentralized control. In this case, the update request still goes to the layer, but the layer basically says, object 1, update yourself, don't bother about it, just go and do it yourself. Object 2, you do the same. Object 3, you update yourself. So how an object gets to be updated is determined by the object itself, not by some containing layer. Advantages of this is it is easy to isolate individual control. If each object does its own thing, that's fine. It only needs to know what it does. It doesn't need to worry about other ones. The downside of it is that if objects need to react and coordinate their behavior with one another, then that makes it a little bit more difficult because they have to go and get the other objects and somehow have a conversation with them and to decide what's going to happen as an outcome. Now, important thing to remember in all of this is that it's not one or the other. You actually can mix and match these if you want to. So it's perfectly fine if you have your level, when you're updating your objects, to think, well, what things can I do centrally that makes sense to do centrally? And what things are specific to the game objects that it's better that they themselves manage their own update. So again, it's a modeling tool that you should be thinking about, potentially using when you come to designing your own game. Doing things in the right order is the next important thing to think about on our list here. And we're going to start off with drawing. So in 2D games, it's important to draw objects in the right depth order. If you look at the graphic that we have on the screen, you'll see, for example, that the castle wall is drawn in front of the background scenery. So when we're drawing this, we would draw our background first of all, and then draw the castle wall in front of it. Other examples, we've got the player. So we can see the player is in front of the scenery, in front of the background. We're drawing the player, but is behind the rope bridge. So again, there is a specific draw order here to make sure things look right. And ultimately, on top of everything, we're always drawing the HUD element. So they're always visible. They're sort of the last set of things that we would end up drawing. So what this means is when we're thinking of drawing the game out, we will want to ask what things need to be drawn first to make sure they are drawing first, and then so on up to the last thing that needs to be drawn. Importantly, that same principle also holds, or to a lesser degree, but certainly does hold, for updating objects. Sometimes we will want to update objects in a specific order. Often it makes sense to get input first of all, and then to look at what the user's told us to update objects, and then look at resultant or knock-on effects from that. So again, the order in which we update can be important, and it should be one of the things that you bear in mind. So key takeaways on this. If we're thinking about designing our game, it will be an iterative process. It will take time. You will not get it right first time. You'll go around, you will evolve, and you will change it. But it is important to actually engage in that process and not somehow to try to do it in your head. That's going to be difficult. Get it down on paper, share it with people, talk about it, iterate, and manage it. Hopefully, you'll start off first of all by thinking about the objects that you have within your game. What comprises it? And then trying to define those objects in terms of, well, what did they do, what things do they need, what graphics do they use, and so on. Beyond that then, you want to ask, okay, properties, how does update, how is it drawn? Final thing then is to ask, how are they related? What types of structures, data structures, levels do we want to use to bunch these things together? And how is this whole thing going to hang together? Following those steps through, they'll give you your basic architecture. And given that architecture, well, we're getting close to the point where we can then start trying to write classes that implement different elements of it.